All right, Miss Teasley here. Today's lesson is section 2.2. That's the title and homework. More on functions and their graphs. So we're going to talk about first increasing, decreasing, and constant functions. So basically, when they give you like the definition, but I'm gonna explain it to you hopefully in a more simpler way. So it talks about increasing function. Increasing function, you think about something increasing, it's gonna rise from left to right. So here, this is an example of increasing, all right? So from left to right, so anytime you're looking at increasing and decreasing functions, you trace your graph from left to right. Decreasing, I will be going downhill from left to right. And constant would be a horizontal line. The one thing you need to remember about increasing, decreasing, and constant functions is when you write your answer, you need to use x values to express answers. Make this a little bit. All right. So it says determine over which intervals the function f is increasing, decreasing, or constant. So I'm just going to go and label. I'm going to go through the whole graph and kind of label what's going on. So here from left to right, I'm going uphill. So from here to here, this point is increasing. This piece here in the middle, from here to here, is constant. And then if I go down, so in this direction I'm going down, this is decreasing. And then from this point forward, I'm moving in the upward direction. So this is increasing. And then this last piece here would be decreasing. One thing I forgot to mention is when you give your answers, you use x values to express it, but you also have to use parentheses. So use parentheses. They call it open intervals. That's what open parentheses are. So I know we talked about using brackets and parentheses, and we use brackets when something is included, but just remember for increasing, decreasing, and constant, you're going to always use parentheses to express your answers. So it says list all the intervals where the graph is increasing. Well, we have these two places where it's increasing, here and here. Now you use x values. Now you can't assume that the graph stops at -5. It doesn't stop at -5. This graph will keep continuing. So that arrow represents, remember, use x values. That arrow means that it starts at -infinity and it increases all the way up to this point. But you want to know what x value is associated with that point. So it increases from -infinity to -2. Then there's another piece where it increases here. From what x value to what x value. The first x value, so since we're using another interval, we have to put a union symbol. So it increases from the x value 1 to the x value 4. And notice how I'm using parentheses. Decreasing, it decreases, let me use a different color. It decreases from here to here. You use x values. The first x value would be -1. And it decreases all the way to +1. And then you have another piece here where it decreases. Remember, you can't assume that the graph stops. So I'm going to put an arrow because it keeps going. So it decreases from 4, the x value 4. That arrow means it never stops, so 4 to infinity. Constant. Constant would be this piece here in the middle. So that's that one flat constant piece. So the graph is constant from -2 to -1. All right, relative max and mins. This is where your graph changes from increasing to decreasing. or from decreasing to increasing. All right, so a relative max in this case will be where the graph changes. All right, so it's going to be a point first of all. So this is a point where the graph changes from increase to decrease. So we're on a graph that's to go from increase and then it immediately changes to decrease. All right, there's only one point where I see that happens, and that's here at x equals 4. So that's considered to be a relative maximum. So the point, the actual relative maximum value, we use y values. And the way that we say it is that we will say that the relative max is 4. So relative max is 4. You put that in the first box. Located at x. Sorry, the relative max is the y value. So let me change that. The location is at x equals 4. The y value that associates with this point here is y equals 2. So relative max is actually 2. Is located at x equals 4. All right. Relative min is where it's the point on the graph where graph changes from decrease to increase. That point will be considered a relative maximum. So if I look on this graph goes from decrease, bam, and then it starts to increase. And that point is here at x equals 1. The actual y value that's associated with is -1. So to answer the question, I would say that the relative min is -1. That's how I was going to look at my math lab. And it's located at x equals +1. So relative max and relative min. The domain is how wide the graph stretches. We talked about this last lesson. This domain goes from -infinity to infinity. Range would be the lowest y value to the highest y value, how tall the graph is. So in this case, my range would be from -infinity, that's the lowest y value, and the highest y value that this graph actually reaches is at 2. So I will say it goes from -infinity to +2. Use a bracket. The zeros of the functions are your x-intercepts, where the graph crosses the x-axis. So if you look at this example, this graph actually crosses at x equals -3, x equals 0, x equals 2, and x equals 5. So my zeros of the function are x equals -3, 0, 2, and 5. Those are your x-intercepts. All right, so that's one question that has multiple parts. I would say the hardest part about this particular type of question is just remembering that when you're expressing your increase and decrease in a constant, that you're using x values. And then remember, relative max and min is the point where it changes from increasing to decreasing, or from decreasing to increasing. All right. So this is the point where I will pause the video and try the example. So I want you to pause the video and try this next example. All right. So now we're back here. So let's look and see. So increasing, decreasing, constant. So you always start from left to right. So I'm going to trace this graph. Here to here, this is just a straight constant piece. And you want to put arrows because the graph never ends. So even on here, I'm going to put an arrow. So it's constant. Then I go from here to here. Oh, I'm decreasing. So that's in a downward direction. That's just decreasing. But when I get to this -2, it starts to increase on this piece. So it doesn't have to be a straight line. It's steady increasing. It's going uphill. So this is increase. Then when I get here at that peak, which is at x equals 0, it's going to start to decrease. And then this last piece, when I get here, this flat piece is constant. So that's how I would go about labeling the graph. Just labeling, go ahead, identify the different parts where it's increasing, decreasing, and constant, and then write my answer. Remember that you have to use parentheses and x values to express increase, decrease, and constant. That's the one thing you have to remember to do. Always use x values. So increasing. The first question says where it's increasing. It's increasing on one interval from what x value to what x value. It increases from -2 and the x value of 0. So that piece here. So from -2 up here, but up there, that point is at x equals 0. It's decreasing from -3 to -2. Union, because you have another interval where it's decreasing, would be from 0 to 2. You also have two intervals where it's constant. All right, it's constant from starting here at this x value, which would be -infinity, and it stops at -3. Union 2, and it continues on being constant out to infinity. All right, relative max would be like these peaks where it changes from increase to decrease. So increase to decrease. Those are the points where you have a relative max. So you have a relative max at x equals 0. So the actual relative max, so to answer the question, you would say that a relative max is 2. It's the y value. And then it's located at x equals 0. That's how they want you to put it in the computer. So the actual maximum value, or the relative maximum value, is the y value. All right, relative min is where it goes from decreasing to increasing. So to answer this question, this graph has a relative min at, well, a relative min of, the point is actually here. That y value that is associated with that point is 0. So I would say the relative min is 0, and it's located at x equals -2. -2. Oops, sorry about that. Clean this up a little bit. All right, -2. The domain, how wide is this graph? This graph stretches from -infinity to infinity. The range, the lowest y value. So there's an arrow, but the lowest y value is this constant piece. And it looks like that associated with -2. So my range, you use a bracket because -2 is included. So from -2 all the way up to the highest peak of this graph is at y equals 2. So 2. And you put brackets. The only ones you have to use parentheses for definitely are the increasing, decreasing, and constant intervals. All right, so hopefully you understand increasing, decreasing, and constant. This next example will be a good example to try also. It's only asking me for increase and decrease in the class, and I'll kind of go through this quickly. All right, but if I were y'all, pause the video and just try it on your own. All right, this graph is constantly increasing. So it's increasing, it's going uphill. So this is increase. Then it changes to decrease. Then you have that constant piece in the middle. And then it starts to decrease. All right, for the rest of the graph, it's decreasing. So the interval where it's increasing, remember, you can't assume that it just stops at -5. You have to assume that there's a possibility that this graph can keep going on. So the only way that I would stop and say that it starts at -5 is if, let me just show you. So if you were doing a problem in my math lab and they have like a closed dot, they're clearly letting you know that like, that's it, the graph stops there. But in this case, it doesn't. So if it did have that closed dot, I would say that it increases from -5 to -1. But since there's no closed dot there, I have to assume that this graph continues on. So it increases from -infinity to an x value of -1. It decreases in two parts. It's decreasing from -1 to 0. Remember, you're using x values. And then union from 1 to positive infinity. This graph never ends infinity. And then that constant piece from what x value to what x value would be from 0 to 1. Moving on to the next part of this lesson. This is piecewise functions. A piecewise function is exactly what it sounds like. It's a function that's pieced together. So out here, where it has the if x is less than or equal to -2, those are your restrictions. So basically, let's look at what they're asking us to do. They want us to find f of -3. Well, if I gave you an equation, you should know how to find f of -3. You will plug in -3 for x. The question is, well, I have 3 different equations I could use. So these are all the 3 functions that make up that piecewise function. So I asked myself, well, where do I plug this -3 into? Well, that's when the stuff over here comes into play. So since -3, so you have to ask yourself, is -3 an x value that's less than or equal to -2? Does -3 fall between -2 and 1? Or is -3 greater than 1? So if you notice the restriction where f is -3, where x equals -3, I will use the first equation because -3 is less than or equal to -2. So I'm going to use 2x plus 8 to get the answer. So in place of x, you plug -3 in. And then when you simplify, that's your final answer. 2 times -3 is -6 plus 8 equals 2. All right, f of -1. Well, if I look up here, -1 will be a number that falls between -2 and 1. So I have to use x squared. Notice how I always write down my equation first. I'm going to have to use x squared to get the answer. So now I'll take -1 and plug it in for x. So this is -1 squared, which is +1. And this next one says f of 2. Well, f of 2 is a number that's greater than 1. So I use this last equation, which equals 1. Well, that's it. I can't plug in 2 for x because there's no x in this equation. The answer is going to be 1 regardless. That means this is the graph. This is the piece of the graph where it's going to be constant. This means that your y value is always going to be 1 regardless of what your x value is. Same thing for when f of 4. 4 is a number that's greater than 1. So I use the third equation and then you stop there. If there was an x value to plug in, then I will plug my x value in for x, but that's it. So here are all 4 answers. All right, use what I did in the first example to try the next example. So you can pause the video and try this example. All right, so now I have this piecewise function made up of two functions, x and negative x. So it says find f of negative 2. So then I ask myself, well, is negative 2 an x value that's greater than or equal to 0? Or is it an x value that's less than 0? Well, it's less than 0. So I'm going to use negative x to help me find my answer. So now that I have x here, I need to take the x out and replace it with negative 2. So negative 2 is just positive 2. Same thing for the next one. Negative 1 is less than 0, so I'm using negative x to get my answer. So this is negative parentheses for x, and I'll type in negative 1 for x. So opposite negative 1 or two negatives makes this positive 1. F of 1 is greater than 0, so I'm going to use x to help me find my answer. So in place of x, you're going to plug in 1, which is 1. And then for f of 2, you use x. And in place of x, you use 2. So the answer is just 2. And that's all to it for evaluating a piecewise function. So now we have to actually graph the piecewise function. And in my math lab, they ask you to graph, and they also want to know the range. They want to know the range and the domain. So let's talk about, we'll do both, domain and range. And I'm also going to show you in Desmos how this looks in Desmos, how to graph these in Desmos, because that may be helpful. So let me see how many examples we have. 1, 2, okay. So I'll show you how to use Desmos also. All right, so the first one says that it says use x plus 2 if x is less than or equal to 0. So what you want to do is you want to create a table. And so we're using x values that are less than or equal to 0. So you always start off with this number here. Regardless if they say less than or equal to, I was going to start off with that number out there, which is 0. So I'm going to plug in 0. Plug in 0 to this y equals x plus 2. So this ends up being y equals 0 plus 2, which is 2. So I'm going to plot the point 0, 2. Then another number that's less than 0, I'm going to use negative 1. So to get the value for this, y equals negative 1 plus 2, which is 1. So this is a point negative 1, 1. I'm going to do one more point. Let's plug in negative 2. So these are all numbers less than 0. So y equals negative 2 plus 2, which equals 0. So this is the ordered pair negative 2, 0. So I'm going to plot the point 0, 2, negative 1, 1, and negative 2, 0. And since it has less than or equal to, this means that this value is included. So since it's included, I'm going to keep it as a closed circle there, and I'm going to connect these dots, and that's the piece of your graph. And you understand what I mean when I say included. Here, I'm going to create another table, x. And then you have y equals 1. Even though it says x is greater than 0, we're going to start off with 0. So 0. And so when I plug in 0, the answer is just 1. All right, the y value is 1. So y equals 1. Even the next number, a number that's greater than 0, will be 1. So when x equals 1, y is also 1. This whole column is going to stay the same as y equals 1. At 2, it's 1. All right, now, why did I include this 0? Well, you do it to create to create your table, but it's not included. So since it's not included, you have to use an open circle. You have to start off with it. You can't just jump and start off with 1. All right, you still start off with 0. So I'm going to plot this point 0, 1. All right, well, 0, 1 is here. But I'm going to put an open circle because it's not included. Then I have the next point 1, 1. Then I have the point 2, 1. So that's your piece of the graph. That's this constant piece. And you have to have an open circle here because remember it has to be a function. So it has to pass a vertical line test. So you have a point up here at 0, 2, but there's no point here at 0, 1. That's how the graph looks. That's how you'll want to sketch a piecewise function. And I'm going to show you how this looks in my in Desmos. So x plus 2 and 1. So to do piecewise functions in Desmos, this is y equals x plus 2. You have to put your restrictions in these fancy little braces. So you go to your table and you hit this button here. And it says that x is less than or equal to 0. So notice how there's your point. So that's the piece of the graph there. Then I'm going to type y equals 1. And so then this becomes, they say x is greater than 0. So x greater than 0. And there's your other piece. If you click on this piece, it says that it's 0, 1, but that point is actually not included. Right? They shouldn't have it there because I don't have that symbol underneath it. But that's why, the technology is good, but you don't want to depend on it completely. So you need to know on your graph it should be open circle. Let's talk about this domain and range stuff of this. All right, so if you look at this graph, the domain, this graph stretches from negative infinity to positive infinity. So negative infinity to positive infinity. Let me move this out of the way. All right, the range. The lowest to highest y value. This graph starts off at negative infinity. The highest y value on this graph is 2. And it's included, so you put a bracket. So that's your range. All right, if I were you, I want you to go ahead and stop and try this example. All right. So here, we're going to start off with this x. So that's the function y equals x. So I'm using a little table, and this is going to be my y equals x column. Start off with 0, and it says greater than or equal to 0. So I'm going to use numbers like 1 and 2 to help me. Since this has a greater than or equal to symbol, you're going to include that value. So that means you're going to have a closed circle at your first point. Closed circle. So y equals 0. So plug in 0 for x. This is y equals 0. So this is a point 0, 0. This is y equals 1. So this is the point 1, 1. This is y equals 2. So this is the point 2, 2. So when I graph this, I have a closed circle here. So that's 0, 0, 1, 1, and 2, 2. Then I'm going to do it at x equals, I'm going to do negative x now. All right, so that's y equals negative x. So here's my other table. So y equals negative x. So here, x is less than 0. You still start at 0. But then you use values less than 0. So negative 1 and negative 2. Just use a few points. So this is y equals negative 0, which is just 0. So that's the point 0, 0. But remember, you're going to have an open circle. Y equals negative x, or negative 1. So this ends up being positive 1. So this is a point negative 1, 1. Y equals negative. The x value is negative 2. Opposite negative 2 is positive 2. So this is negative 2, 2. So now when I plot these points, the first point I'm plotting is 0, 0. And it says open circle. Well, I can use an open circle, but the darkened circle was already there. So it's going to stay closed. So that darkened circle that was there from the beginning, even though I'm putting an open circle over it, if you notice, it's still filled in. Negative 1, 1. And negative 2, 2. This is the other part of that graph. Looking at this graph, your domain is from negative infinity to infinity. Your range is from 0, 0 is included, to infinity. So if it was just an open circle and that circle wasn't filled in, I would put a parentheses around 0. But since it's included, you put a bracket. That's your range. And I'm going to show you how this looks in a graph in Desmos. So let's see. So I have y equals x. And this is, you put the braces if you want restrictions. This is when x is greater than or equal to, there's a symbol right there, 0. There's your first piece. And then you have y equals negative x. And the restrictions is when x is less than 0. There's your other piece of graph. All right, one more piecewise function. Again, pause the video and just try it. All right, so try it. This is made up of 3 different functions. All right, so let's start up with the first one, 2x plus 8. So over here to the side, I have my x column. This is the one that's y equals 2x plus 8. You start off with negative 2. It's going to have a closed circle because that line is there. And it says x is less than or equal to negative 2. So a number that's less than negative 2 would be negative 3. And a number after that that's less than that would be negative 4. So I'm using this equation, y equals 2x plus 8. So 2 times negative 2 plus 8. So that's negative 4 plus 8, which equals 4. So when I plot this, this will be negative 2, 4. Then I have to do 2 times negative 3 plus 8, which is negative 6 plus 8, which is 2. So that's the point negative 3, 2. Then I have to do 2 times negative 4 plus 8. So that's negative 8 plus 8, which equals 0. So that would be the point negative 4, 0. So starting off with that first point, negative 2, 4. So negative 2, 4 will have a closed circle. Negative 3, 2. All right, and we don't have enough points to do 4, 0. I guess it would be here. So it looks like this is a line. It would keep going. Then notice they have this piece here. This graph, they tell you it starts with negative 2 and it ends with 1. At x equals negative 2, you're going to have an open circle. But on the side where it's x equals 1, you're going to have a closed circle. And that's because this is less than or equal to, so that makes it closed. This only has a less than symbol, so it's open. So when you create your table, x and y equals x squared, you start with negative 2. So it says x falls between negative 2 and 1. So negative 2, negative 1, 0, and you stop at 1. So this would be negative 2 squared, which is positive 4. This is negative 1 squared, which is 1. And this is 0 squared, which is 0. 1 squared equals 1. So I'm going to write the ordered pairs beside it. So this would be, let me go back to that same color. This would be negative 2, 4, negative 1, 1, 0, 0, and 1, 1. So at negative 2, 4, we talked about negative 2 should have an open circle. So at negative 2, 4 should be an open circle. Well, use a different color. Well, even though putting an open circle, there was already a closed circle there. So it would just stay closed. So you in my math lab, you would just be choosing the correct graph. Then you have a point at negative 1, 1. There's a point at 0, 0. And there's a point at 1, 1. All right, this is that U-shaped curve. Now, at x equals 1, there should be a closed circle. So that's how it looks. It's closed. Then you have this last function, y equals 1. So x and y equals 1. That means it's going to be 1 regardless of what x value you use. They want you to start off at x equals 1 and numbers that are greater than that. So 1, 2, let's say in 3. At x equals 1, because that's just a greater than symbol, you're going to have an open circle. So regardless of whatever x is, y is always going to be 1. It's just going to be 1 at every single point. All right, so y equals 1, y equals 1, y equals 1. I'm just going to write. There's no x value. There's no place to plug your x value into, so it's just going to stay y equals 1. So this is the point 1, 1, 2, 1, and 3, 1. So let's see. 1, 1, there's an open circle. Oh, well, there was already something there, so I'm just going to, even though I'm putting an open circle, it's filled in, so it will stay closed. 2, 1, and 3, 1. All right. Your domain for this graph, how wide is this graph? It goes from negative, sorry, I didn't mean to put braces. Your domain is from negative infinity to infinity. Your range. This arrow down here means the graph never ends, so it starts all the way down at negative infinity. However, the highest peak is here at the top at y equals 4, so it goes up to 4. I'm going to show you how this graph looks in Desmos. So 2x plus 8 less than or equal negative 2. So let's see. So the first one is y equals 2x plus 8. I think it's x is less than or equal to negative 2. And then you have the part y equals x squared. And it goes from negative 2 to 1. So at negative 2, so you type negative 2. Then there's a less than symbol. Then you have an x. Then you have a less than or equal to 1. So there's that piece in the middle that we graphed. And then the last one is y equals 1. And this is when x is greater than 1. There's your 3 different pieces of the graph. So that's your piecewise function. All right, those definitely take a little bit of practice. So make sure you're doing your homework to get you some practice in. All right, the last part of this is the difference quotient. All right, so we have to evaluate this difference quotient. So they want us to find f of x plus h minus f of x, and then divide all that by this variable h. Well, the good thing is they give us f of x plus h. So that's given. So this is always going to be given. What we have to do is find out what f of x plus h is. So find f of x plus h. So to find f of x plus h, you start off with f of x. So f of x equals 2x plus 3. So to evaluate a function like this, you take the x out the picture by putting blank parentheses wherever you see x. And inside the parentheses, you put x plus h. So wherever there's a parentheses, you put x plus h. And then you simplify the right side. So when I distribute this, I get 2x plus 2h plus 3. And that's it. That's what f of x plus h equals. So let me write down what we're doing. So they give you this big old fraction, f of x plus h minus f of x all over h. So I'm going to kind of highlight it with different colors. So to get the first part of your answer that I have in pink, in that pink spot, you need to put all this stuff here. Then it says there's a minus sign in the middle. And then you have this f of x. F of x is what's given. That's this stuff right here. This is what f of x equals. So that's what goes in this spot here. And then you divide that by h. So the pink stuff is 2x plus 2h plus 3 minus f of x is 2x plus 3. Put parentheses around it. Anything that follows a minus sign, you want to put a parentheses around it. And then it's all over the letter h. And then you simplify this. So this is 2x plus 2h plus 3. When I distribute this minus, I get minus 2x minus 3 all over h. And then stuff should start simplifying. If you notice, the 2x cancels out. The 3 and negative 3 cancels. So I have 2h over h. And when you simplify that, the h's cancel out. So you get 2. So I just want to give you a little trick, an easy way to get the answer with problems. Like, and it only works with problems in this form, 2x plus 3. If you notice, whatever's in front of your x, like in this case, I have a 2x, that's what my final answer is. Because this difference quotient, they use it to find slope. We'll talk about slope in the next section. But if you're familiar with slope, that's what this is used for. It's used for slope because in higher level math, we can find slope of curves. But since these are lines, we already know that the slope is going to be the number in front of 5. All right, so let's just see how does that work. So go ahead and pause the video and try this example. And once you do all the work, you should get 5 as your final answer. All right, so here's the difference quotient again, f of x plus h minus f of x all over h. So this is going to be, to find f of x plus h, you start off with f of x, which is 5x minus 6. And then in place of x, you put in x plus h. So this is x plus h. So when I distribute this, I get 5x plus 5h minus 6. So this stuff in blue, I'll highlight it using this color. This answer goes in place of the f of x plus h. Oops. And then the f of x is what's given. So that's what I put in there. That's given. So you just put that where it says f of x. So it's 5x plus 5h minus 6 minus, make sure you use parentheses, 5x minus 6 all over h. So I get 5x plus 5h minus 6 minus 5x plus 6 all over h. These cancel out. The 6 cancels out. I'm left with 5h over h. The h's cancel out. And you're left with 5 as your final answer. And if you notice, if you go all the way back to the beginning of the problem, it was f of x equals 5x plus 6. The number in front of your x is 5, and look what I got as my answer. All right, I'm just going to do one more just in case you run into one of these in homework. You won't have one like this on your test, but I just want to make sure that I cover it just in case. This one is not so simple. It has an x squared, so you can't just figure out what the answer is by looking at it. So again, I have to do this f of x plus h minus f of x all over h. So this is f of x equals x squared plus 1. Replace all my x with x plus h. So when you square this is x plus h times x plus h. And you have that plus 1 behind it. So we have to multiply this out. We did this before in another example in a previous lesson. But you'll use FOIL or the distributive property. Make sure when you multiply variables, you put them in alphabetical order. So x times x is x squared. X times h, I'm going to write it as hx. Then I come back and multiply everything by h over here. So h times x, again, is hx. And then h times h is h squared. Then you have a plus 1 all over h. Then you have to subtract f of x from that. Remember, f of x is given, so that's in parentheses x squared plus 1. These two I can add together, so this is x squared plus 2hx plus h squared plus 1. When I distribute this minus, I get negative x squared minus 1 all over h. Yeah, this is a pretty intense problem. The x squareds cancel, the 1's cancel, and what you have left is a 2h plus x plus h squared over h. You want to simplify this by factoring the top. So the only thing I can do at the top is factor out the greatest common factor, which would be h. And when I do that, I'm left with 2x plus h all over h. The h at the top and the bottom cancels out, and this would be your final answer. So it's not just a simple number like the rest, but that would be your final answer. All right, and that's it.